consider what's going on as far as nature is concerned. But look at that psalm just for a minute. Look how it begins. The heavens declared the glory of God, and the firmament showeth his handiwork. Now what he's saying to us is, if we go a little further on, look at verse 7. The law of Yahweh is perfect, converting the soul, and the testimony of Yahweh is sure, making wise the simple. So you see, even the creation of heaven, he says to us, there's something we can learn from it. Again, look at the next verse. The statutes of Yahweh are right, rejoicing the heart. The commandment of Yahweh is pure, enlightening the eyes. So what we're going to do this afternoon is look at some of the creative things that Yahweh's done and what he's really trying to teach us, I believe, in some of those things. So nature's evidence that there is a God. There's the psalm we've just looked at. The heavens declare the glory of God. Now just look at that picture there. That's a great host of stars that we're looking at. And that looks like a cloud. It's so intense. The heavens declare the glory of God, and the firmament showeth his handiwork. Day unto day uttereth speech, and night unto night showeth knowledge. Well, that's what we're going to be looking at. God willing, if the time permits, if it goes on a little bit longer, and I'll just cut it. So you're certainly able to ask questions if you like, or some of the younger ones might, if they're with us. But what we're going to look at, first of all, that God is a God that is all-knowing. Now, how do we know that God is all-knowing? Well, have a look at this. Here's some of the telescopes that we've had that are made during the 1900s. Okay, developments that are made in that 1900s period. Look at it, 200-inch telescope. Here's a telescope that goes out into outer space. No clouds, no mist can befuddle that. That's the way it is. And here's one, a radio telescope on the right there. So we can find all sorts of things in our study, but you know, we've got a book here that's already told us. Look at this. What's the earth like? Well, in Columbus's day, they said, well, Columbus, you're crazy sailing across to America. You'll sail off the edge of the earth and you'll crash somewhere and you'll kill yourself. The Bible says that the earth is curved. We could look at it if we like. I don't know how our time will be. I think there'll be plenty of time, but it doesn't matter. Isaiah 40 verse 22 says, is it he that sitteth on the circle of the earth, and the inhabitants thereof as grasshoppers? Now, you think about it. There we are. Way back then, in 1492, they said it was flat. But if you go BC, 720, the inspired Bible says the earth's curved. Isn't that incredible? Incredible. As well as that, in that same verse it says, it is he that sitteth on the circle of the earth, there's that verse, that stretcheth out the heavens as a curtain, and spreadeth them out as a tent to dwell in. So you see, that means around the earth there's like a curtain. What is it? It's the atmosphere. There it is. There's the earth's atmosphere. It's in between those two dotted lines. We know that. That's what we breathe. Without that, we wouldn't survive. Way back 700 years before Christ, the Bible's telling us that. They had no idea about it. As well as that, Job says, he that stretcheth out the north over an empty place and hangeth the earth on nothing. You know, back in the Greeks' days, they said the earth was on the back of some god. Somebody had to be supporting it, didn't it? But the Bible, long before that, Job, one of the earliest books ever written, says it hangs on nothing. On nothing. Well, that's what outer space is. It's nothing. Just seems to be just suspended there. Okay, we know gravity holds it and keeps it in its orbit, but it's suspended on nothing. There's not a physical thing out there. The Bible says so. Isn't that truly amazing? Again, come to Job in our mind. Job says, canst thou bind the sweet influences of Pleiades? Now, Our Oxford Bible in the margin says Pleiades is a Hebrew word that means 7 stars. Oh, 7 stars. Or loose the bands of Orion. Canst thou bring forth Mazzaroth and its Caesars? There are other groups of stars. Here we are. Let's now look at Pleiades. Well, I know all about Pleiades because I've got a Subaru. And there's the bonnet. There's what the Subaru, the front of the Subaru looks like. Okay? It's got Pleiades on the front of it. Here's a picture of Pleiades. There it is. That was a few years ago. That picture came up on the web. Okay? Count the stars. 6. The Bible's wrong. Or is it? With the new spaceships, with the telescopes on board, blow me down, they found a 7th. The Bible was right. Before they built any telescopes or anything like that, it said 7 is in that constellation group. 7. And crazy Subaru made a mistake, didn't they? Made look like idiots, driving around with 6 on the front. Well, now we know there are 7. Okay? Now, don't hesitate, particularly the young ones, if you can't follow it, ask a question. I might not be able to answer your question. I'm not terribly smart at my science nowadays, getting quite forgetful of it, but I'll try. So don't hesitate. And the rest of you too. All right? Well, let's push back to that quote we looked at before. It went on to say, canst thou guide Arcturus with his sons? Who's Arcturus? Anybody know? Well, there's a picture of him. There's Arcturus. It's a big star. And here's the Earth, just to show a comparison of sizes. Arcturus, size-wise, across it 25 times bigger. And it's so intense, it produces 100 times more light than the Earth, than the Sun. So there we are, Arcturus. And Arcturus, well, it says, can't thou guide it? What does that mean? Well, it means it's moving. We didn't think so, because when you look out in this outer space, if you looked out 200 years ago, there's a group of stars and it stood there. You look today, there it is there. But have a look at its colour. It's a reddish colour. Now, when a star is reddish, it's usually moving away from us. When it's a bluish colour, it's coming towards us. Red waves are stretched, blue waves are squared, closer, you see. So it's moving away. So they did a little calculation, they came up with the sums. They said, yeah, it is moving. It is moving. It's moving at 430 kilometres a second. Anybody got a car that does that? Speed? Oh, you have, okay. All right. Or 1.5 million kilometres per hour, not bad. You better have a chat to him, he's got a pretty good one. Okay, so there we are. So what does it tell us? God knows. God is all-knowing. He knows all this data. And he's recorded a lot of it in Scripture. Isn't that amazing? We have no idea about these things till the Bible had written it. And then we discovered it afterwards. Incredible, isn't it? But God is incredibly powerful. Ooh, very powerful. Do you want to see? Well, let's have a look at it. Who can understand the thunder of his power? Says Job. The thunder of his power. Well, how's it stored? Or how can you use it? Well, I'm only going to use one example. We're going to use something pretty calm. Water. There's the formula for water, H2O. Okay? Hey, is that water? Any of the young ones? Is that water? Yes, please. Tell me. Yes, no. What is it? That stuff there. Ice. I hope I heard it right. Yes, you're right. An iceberg. So there it is. It's another form of water. And, all right, well, let's move on. You see, water has a wonderful structure. That's the water shape, H2O, 109 degrees, 28 minutes, or degrees. I think I've got a 2 out there. Should have been 28, 25, doesn't matter. 109 degrees per angle. Okay? Now, why? Well, water, the little bits come together, but when you freeze it, it can join up, and that makes it space out Put space between it. So you see, it's got a wonderful structure, and when you freeze it, you can do some tricks with it. It has also got a very powerful change of state going the other way. Goes from water to steam. All right? And lastly, although it's not quite water, but I'm just playing around, we're going to look for a minute at this stuff. 2 parts of hydrogen, put it together, and we're going to make helium. That sounds like good fun, doesn't it? Something you want to do in your backyard all the time, don't you? Well, we'll talk about it later. Okay, hast thou entered into the treasures of the snow? That's ice. Or hast thou seen the treasures of the hail? Said God. Well, look at it. It's incredibly beautiful. Look at this. You get it under a microscope and have a look at the structure of it. Every little bit of that is different. There's a different crystal arrangement. It's absolutely unfathomable in its complexity. Here's just a few of the basic shapes that all join together. Here's just a few more of the drawings of them, some of those particular shapes. So here it is, watered, usually a V shape like that, but joining up like this. And it joins up in all sorts of pretty patterns. But God said that in Job, way back in that time. So here we are, let's have a look at it. There's a bit of water all joined together. See, as I was trying to show you a second ago with my thumb and fingers, it joins and spaces itself out. So, hey, listen, it floats like a boat. But the ice floats on it. Yes, please. Nice and loud, though. Excellent. Top of the class. Top of the class. Boy, nobody else could do that. That's wonderful. All right. In water, the 2 hydrogen atoms form a V shape. Okay? On the oxygen. In ice, the water molecules are forced into a 109 degrees, 28-minute angles of tetrahedral crystal structure. Okay? So that gives you a little bit of a picture of it, of what can happen. So here's a little bit of an iceberg. I just thought I'd show you this one. Look at this. This floats like a boat, but it's a lump of ice. How much is underwater compared with that's on the top? Yeah, something like that. Yeah, it's a huge amount. So it's amazing. About 3 times below, about 1 time above. Something of that figure. It's actually a little bit more, but doesn't matter. There we go, about 9% lighter. So it's really amazing. Well, water. It can change state. It can also become steam. And it can vaporise. It did so in 1883. This volcano, that's a picture of it way back then. That's why it looks shaky. Or pretty poor picture. It cracked open. The volcano just split and the sea got into it. And they could see it from long way away. They saw the water go as it went to steam. Then a bit more water went in. Then a bit more water went in and the mountain just blew up. Just blew up. So here it is. Here's some of the volcano at that stage. And there's the lava coming down the sides. And then it split open. And when it split open, look, this is photographs taken way back then. And here it is. Here's where it is, Krakatoa. If you can't work it out, there's Sumatra. There's about Singapore and such like. Australia's just over here. When it split open, it blew the whole mountain pretty well away. That's all that left. That whole part was the mountain. There it is. That's what it should have been. Sorry. Krakatoa. And that's all that's left today. So when it went off, there's the map. Remember where it was? Somewhere over around here. Look what happened. Boom. The noise was, they say, the loudest noise ever heard or ever recorded. Probably there's been louder noises, but nobody can tell us that or prove that. A cataclysmic explosion was distinctly heard far away as Perth. Down in Perth they had boom, all the way from Indonesia. That's a big bang. That's a big bang. Even over here at Madagascar, up in the Philippines, the bang was heard. But something else happened. Can any of the children tell me what might also have happened? Oh, this is what happened. Waves came from the shock wave. And the shock wave, well, it's supposed to travel initially at the speed of sound. Of course, it slows down very quickly in water. But it travels up to about 200 kilometres per hour. It's a tsunami. And when that tsunami hits land masses, look what happens. We haven't got pictures back then, but we have back in 2004. There it is at Sumatra area. Here's the tsunami coming across the coast. Look at the damage it did. Huge. 200 kph. Amos says, "Seek him that calleth for the waters of the sea and poureth them out upon the face of the earth." Scripture almost seems to be speaking there of a tsunami. And tsunami it was, huge effect, when this erupted there and did quite some damage. Incidentally, just a curious question, seeing we might like to do a bit of science thinking, why didn't it damage Singapore over here? Well, I tell you what, it damaged parts up there above Malaysia, but not below the word Malaysia. Anybody like to tell me? Well, I tell you what, the shock wave won't go around an object bigger than its wavelength. Okay? So the wavelength was the thickness of Sumatra. The wavelength got around it, but when it went a bit angular, it didn't hit Singapore, thank goodness. We came to Singapore just a little afterwards, and all the high-rise buildings would have collapsed. If it had hit, it would have done horrendous damage. But a little ship, there it is. Actually, it's quite big. It got taken 2.5 kilometres inland and dumped. It's still there today. Okay, it's a bit of a wreck, but there it is. So here's that volcanic eruption. Just one eruption, Krakatoa, caused the largest sound ever heard that's remembered, and was heard 3,000 kilometres away in Alice Springs, Perth, the Philippines and Madagascar. Okay? Estimated power equal to 21,000 atom bombs that dropped on Hiroshima size. You know, that sort. Okay, they were only baby atom bombs. Krakatoa was 2,000 metres high with a radius of 9 kilometres, but was almost completely wiped out. Boy, this is incredible. It produced a number of tsunamis reaching 40 metres high and travelling as far as the English Channel. It got around, and they reckon they could see in the English Channel waves only a few centimetres high, shooting along about 200 kilometres per hour over the top of the other waves. So it seemed to be a shock wave. The eruption destroyed 3/4 of the mountain. The steamship, as I said, Baru, was thrown 2.5 kilometres inland, and the ash and stone hail was thrown over an area of 300,000 square kilometres, or a radius of 150 kilometres. Ships coming from Perth, going to India, in some parts didn't see the sea. So much pumice was blown out, they were just pushing through the floating rock. You know, pumice is floating bits of rock. And over in London, when they couldn't take a picture, but somebody painted it. Here's some pictures. And for many months, the sky was like that. It coloured the sunsets, and that was the effect of it. And it changed the world's temperature for years because they had so much dust reflected out, and it cooled the earth. So you see, amazing things happen. There's God's power. But you know, there's another one. Here we are, the hydrogen. Two hydrogens come together, squeeze them together, and you make them into helium. So let's do it. Well, it caused the Big Bang. 3,500 times bigger than Hiroshima. The hydrogen bomb tested on 29th of March 1964 was one of the biggest ever. Well, all those things are using what God has made. So it tells us God's power is supreme. Now unto him that is able to do exceedingly abundant above all that we ask or think, according to the power that worketh in us. God's power. So you see, brethren and sisters, God is all-knowing. But not only all-knowing, he has incredible power. Incredible power. Now what we want to see also is that God cares. God cares. He cares for us. And we can see it in creation around us that God is caring for us. Isn't it amazing? Here we are. God cares for us. There's a photograph of outer space. Here's some of the stars out there. Yeah, it's a pretty powerful telescope, isn't it? But there's some of the stars. Now, the heavens contain, they say, 10 trillion billion stars, which are very beautiful. But they also can be very, very dangerous. Very dangerous to life. Not a very safe spot to be. Oh, it is beautiful. Look, there's the Horsehead Nebula in outer space. Okay? 1,500 light years away from us. There it is. Isn't it beautiful? Looks really quite picturesque. But outer space is dangerous. But where we live, well, we call it the Goldilocks zone. Children know all about Goldilocks. Who's Goldilocks? Anybody like to tell me? No? All right, don't worry. It's a bit embarrassing. Okay, well, they call it the Goldilocks zone because it's nice and safe. Okay, well, we'll see why. Let's have a look at outer space for a minute. Oh, did I press it twice? There we are. Sometimes stars collide. Sometimes stars explode. They can be, in those situations, exceedingly dangerous. So if our star, the sun, collided with another one, ooh, things dangerous could happen. Right? Well, let's have a look at something. Here we are. Here's some photographs taken only a few years ago. 2009, two galaxies. Now remember, a galaxy is a mass of stars collided. Boom. Now, what happens is, of course, a bit of space there, so some of it went right through another one. But other times they hit and collided. Look what happened. So they collided, there they are. And here's the consequence. They coalesce for a moment. And then, look what happened. Then some collided, some passed straight through, some hit with the others and went out like that. You wouldn't want to be there, would you? So outer space is a pretty dangerous space to be. Pretty dangerous. Not what you want to be. So stars, as I said before, sometimes explode, sometimes they collide. They are very dangerous spots. Our sun is a star. But you see, the three types of galaxies, according to the experts, they tell us, but there's only one of them that's safe. And only one spot in it is safe. And that's where we are. There's three types. Only the spiral galaxy over there is safe. And see where the Earth is? There it is. So they're very dangerous. So is our galaxy, except in that little spot. Safe in only a few places. Between the swells, it's safe to be. Okay? So that's where Earth is. There, in one of those spots. Between the two swells. So you can see, we're in a safe spot. God has cared for us. And here's our galaxy. No, the universe, isn't it? No, the solar system. My apologies. Half asleep at the moment. I should have had a coffee, shouldn't I? I had a cup of tea. It didn't work. All right, so here's the solar system. And they're all crumpled together, put together so we can get them all into space in the same picture, so that they're in their proportional sizes. Okay? So you can see, there we can see the various different ones represented for us on that picture. But here's an expert, Isaac Newton. Isaac Newton said this most beautiful system could only proceed from an intelligent and powerful being. Now that would have to be one of the most intelligent scientists ever known. And he was certainly a worshipper of God in the end, or tried to. So what's different about our star, or our planet? Well, first of all, it has 26 essential elements, as well as water, carbon, iron, oxygen, silicon, so on. Some of those are critical for life. As well as that, we receive blue light, which is needed for photosynthesis, higher, shorter energy, shorter wavelength, higher energy light for photosynthesis. So you can get pictures like this. Anybody know where that is? Yeah, New Zealand. Yeah. Okay, Milford Sound. There it is. But you can see the blueness. And you can see also some of the, well, you can't see the oxygen, but it's up there, isn't it? And usually there's plenty of water raining down there too. But there we are, our beautiful earth that God has made. It must have the right temperature range. I could do with it a bit warmer today, but it's safe. It's safe. You see, the earth is at the right distance from the sun, so it's not too hot like Venus, 460 degrees centigrade. Back about I think it was about the late 1950s, they sent a spaceship to Venus to see if it was safe. But Venus is covered with cloud, so they didn't know what it was going to be like. But when they got in there, it was quite warm. 460 degrees centigrade, the spaceship just melted. Okay? What about Mars? Idiots at the moment, they're saying, let's go to Mars. Mars is, well, it's not that bad. It's got an average temperature of minus 60 degrees centigrade. Can anybody tell me something that freezes at about minus 40? Carbon dioxide. So you'd be going on, breathe out, clatter, 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 breathe out, clatter, clatter, clatter. The carbon dioxide would hit the ground as you went along, as stones. Woo! So there we are, there's Venus. Venus has a temperature of 460 degrees centigrade and is mostly liquid. What about Mars? Minus 60 about that. There is some parts where the sun's on it, it's a lot warmer, but the average temperature is around about minus 60 degrees centigrade. They're talking about going there. They're crazy. Do you know what? They just said only about 3 years ago, we sent a spaceship to Mars. And the spaceship got outside of the Earth, and I'll pick this up a bit later on. They said, yes, we could travel to Mars, we'd be safe from radiation, provided we had a spacesuit around us, 1 metre thick of steel. Any of you could carry that? I'm sure you could, but I couldn't. That's the way, because the sun's radiation outside of the Earth is so deadly. More on that later. The minimum background radiation is achieved by the atmosphere. Here we are, here's on the Earth. Around the Earth is what we call the ionosphere. We won't go into it in any great detail, but it absorbs certain types of radiation, wave radiation from outer space. We get a bit too much when we get sunburnt, okay? But if you went outside of that dotted line, the sunburn you'd get would kill you. It's deadly. So you see, when it comes in from the sun, it hits that and bounces out. So we're safe inside. As well as that, as I said a moment ago, outside the Earth is also another type of radiation, particle radiation, little tiny bullets, like hydrogen atoms or helium atoms, travelling, and they're charged, travelling around about a third of the speed of light. If it hits you, it would kill you. Unless you had that lump of steel around you, 1 metre thick. Anybody got a spacesuit at home that big? Oh, well, you can't go to Mars. Forget it. You know, it's so bad that, well, you can get to the moon. It's not so bad there. You're still under the magnetic protection of the Earth. See the magnetic field? It diverts that form of radiation from the sun and protects you. Make sense? Okay. We have moderate seasons. What causes our seasons? Well, it's beautifully designed. Look, the Earth's inclined at 23.5 degrees. So one side gets winter, pity. The other side gets summer. But then 6 months later on, it's back to nice again. All right? So you can see, God has built our Earth beautifully. It's in the Goldilocks zone. And it's perfect. You go down to the beach, the tides come up, go back. Any rubbish? Taken away. Any rubbish coming down the rivers? Taken away out to sea. So you see, tidal influence is due to the moon as it circles the earth, lifting the seas. Sun does a little bit, but we won't go into that. All right? But out there's bullets flying around called comets. They're only little ones, 20 kilometres across on average, a comet. That's quite big. You think about it. We probably came 20 kilometres, not quite that, from where we came up near Parafield Airport. A bit of an idea, about the size of Adelaide. Okay? These come, and they come at quite big speeds. But you see, why don't we get hit by these big bomb bullets? Well, what protects us is Jupiter, Saturn, and the asteroid belt. Here's a belt of stones out in space, swirling around. They're outside us. See, here's us. And you see, they protect us. Well, let's first look at Jupiter. Here we are. Jupiter, huge, 300 times the size of the Earth. There's Saturn, about the same size, I would imagine. Can't remember exactly, but doesn't matter. Dangerous comets and meteors are drawn off course by gravity. And they usually hit Jupiter or Saturn rather than the Earth, because Jupiter and Saturn, travelling around in the same basic path, protects us. So you see, here we are. And there we are, there's the asteroid belt. There's Jupiter, I haven't got Saturn on there. Picture didn't have it. And there's a comet coming in. And it's Jupiter. Or alternatively, things like meteorites. What do? They might hit Jupiter or Saturn, or they are protected by this belt of gravel, not gravel, but the big lumps of stuff out there called the asteroid. And that protects the Earth for the key main part of it. All right? So there we are. So God has loving care for us, hasn't he? That's all right. God so loved the world that he gave his only begotten Son, that whosoever believeth in him, should not perish, but have everlasting life. And the world through him might be saved. So you see, God is wonderful. He cares for us in a most beautiful way. So coming back to our headings, God knows what's best. He has the power to help us, and he cares for us. Now, we only got a few more minutes later. Hopefully we'll get there. God calls us, so he said, so let us hear his word. Well, how does he call us? I don't suppose you were the one on the left there, but he gives us ears. Okay? That fella's got a few big ones. But there we are. That's a bit like us, more on the right-hand side down there. God gave animals and man the capacity to hear, and therefore to respond to what he calls on them to do. So let's take an animal. I just thought I'd get a nice, cute one. There he is, the biggest animal on earth, the whale. 33 metres long. I don't know, how long is this haul? I would probably think it's maybe 1.5 times this. Yes, Max?
11 metres wide.
Okay, so 3 times wider than this. That little fish is that size. Okay, is he little? No, top of the class. Well, there we are. Blue whales are the largest animal ever known to have lived on Earth. They are up to 100 feet long, or 30 metres long, and weigh up to 200 tonnes. Even their tongue, only a little baby thing, it almost can weigh as much as an elephant. So he waggles his tongue. It's quite a big waggle, isn't it? All right? So, and not only that, he can jump out of the water. 200 tonnes of it. Pretty powerful, isn't he? There is he leaping out of the water. And there he's compared to dinosaurs. He's bigger than them. Even the biggest dinosaur known. So the blue whale can produce loud noises. As well as he's being big, he's got a big tongue. So he makes a lot of noise when he wants to make it. He can make a noise of 188 decibels versus a jet engine, 140 decibels. So he can make a lot more noise than that if he wants to. And communicate with other whales up to 1,600 kilometres away. So here's our blue whale. Let's put that distance on the map. There it is. Now, he wants a girlfriend. So what does he do? He whistles. Here we are. There's his whistle. And guess what? She comes. She comes. Isn't that wonderful? There's the power of God. Isn't it? Who made that? But now, let's pause and think. God calls us. So then faith cometh by hearing, and hearing by the word of God. But I say, have you not heard? Look at what God has done in all the wonderful things he has created. And he is also calling us through this book. Calling us through this book. Yes, verily their sound has gone out into all the earth. That book has gone everywhere. And their words unto the end of the world. So the issue. Have you heard it? Are you listening? Well, if so, we can hear his word. And what does he do? He calls on us to hear the gospel and be baptised that we might be saved. I put that black one in case I didn't have enough time, but I've got 5 more minutes. So let's have a look at it. God gave animals and man the capacity to see and find their way around. So there's us, and here's a bird. We've got eyes. Now, can evolution produce an eye? By no chance. The light-sensitive retina, the back of our eye, contains over, listen, 10 million photoreceptors, that like little tiny cameras that detect the light and puts the whole picture together. These cells capture the light pattern formed by the lens and convert it into complex electrical signals that send it to your brain and even down to your heart, which are then sent to special areas of the brain where they are transformed into the sensations we call vision. Okay, amazing. So here it is. Let's have a look at something happens when somebody calls. There's the migratory patterns of birds. How do they do it? Well, I'm not going into it in any great detail today because I haven't got any time, so I've taken that out. But I'm going to look at one particular group of animals or birds. The Arctic tern, that's one of them, migrates up to 44,000 miles every year. There's a few migratory birds, some of them. But the one I want to pick up is this one because his migration is almost totally over sea. So I can't see much. But there he is, the great shearwater. He migrates around to about 12,000 miles each year. All right? Okay. He gets born and becomes an adult about April. Then he migrates to North Atlantic and returns south in September. So here he is, born down here. So here we go. Let's see if I've got it right. Hang on, what am I doing wrong? That's supposed to go ahead. Oh well, I've done something wrong. No? All right, that's what I wanted. That'll do for the moment. I think I better come back. Oh, there we are. It's done it. I don't know why, it's supposed to move. So they migrate from here, right up to here, each year, and back down here. Over the sea, and they don't get lost. Oh, they could get blown off course. But how come? Well, they now found they've got a magnet in their head, a compass. They do know where they're going. And not only that, they can find the dip of the magnetic field of the Earth. At the equator, it's like that. At the North Pole or South Pole, it's like that. Or like that. But the dip of it, they detect correctly and can find that island. They don't miss. They are absolutely incredible. And here's the island. Whoops. Only a little tiny island, really. Way out 3,000 kilometres from any other island. They don't miss. Oh, they can get blown off course, but they'll come back to it and try and get back to that island. Incredible. Incredible. So, you see, God calls on us to hear and guides us as he guides the animals. The light of the body is the eye. If therefore thine eye is single, let's hope little bit like Ruth. Thy whole body shall be full of light. Behold the fowls of the air, for they sow not, neither do they reap, nor they gather into barns, yet their heavenly Father feedeth them. Are ye not much better than they? So you see, brethren and sisters, coming back to our pattern, there it is. God knows. God has the power. He cares for us. So let us hear his word. And when he calls on us, then respond. Hear the gospel. Be baptised. And then we will be saved. That's really where we should be going. Very simple steps. This is what the Lord said to us. Go you into all the world and preach the gospel. He that believeth and is baptised shall be saved. Now we know that's certain and sure. That if we do that properly and truly as he said, we will be saved. You look at nature. Look at what it's done. And we can see, without any doubt, that God is somebody who will accomplish that whereunto he is sent, or sent others. Then indeed, for us, we have the hope of salvation.